This is the Buck Scientific installation and basic operations training video for the simplified Model 205 atomic absorption spectrometer. When you receive your instrument, unpack it and lay out all of the parts and supplies, such as the gas tank regulators, connecting fittings, tubing, drain hoses, and spare parts. The basic installation kit will include a dust cover for the instrument, a bag with a series of 1/4-inch swage lock fittings, a series of hex wrenches for removing the burner head and drain block, power cable, and some nylon tubing for the gas lines and Tygon tubing for the drain line. Ignition of the flame is accomplished with a barbecue lighter enclosed with the installation kit. To continue with the installation setup, you will have to connect the electrical power cord for the instrument, create a gas-tight swage lock fitting for the gas lines for the air and acetylene and nitrous oxide if used, attach the Tygon drain line with a loop to prevent flashbacks, and insert the hollow cathode lamp for the element you are going to use for your first analysis. The back of your Model 205 AA will have your connections for the electrical power supply and for your gas lines for air, acetylene, and nitrous oxide if used. To prepare a swage lock gas-tight fitting, make sure that you use the nylon tubing included with the system from Buck Scientific. Make sure the end is cut square, and then place the nut on the end of the tubing first. Then the small donut-shaped ferrule with the narrow end facing out, and then the cone-shaped ferrule, again with the small end facing out. Fully insert the tubing into the fitting, push the ferrules and the nuts forward, and hand tighten as much as possible. Once the fitting is hand tight, tighten it with a wrench 1 to 1.5 times, and this will create a gas-tight fitting where the brass ferrule will grab the tubing and give a good seal. Repeat this for the other lines, and we will proceed to install the instrument on the laboratory bench. Before connecting your electrical power cord, make sure the little voltage selector switch is set for the proper voltage for your operation, whether 110 volts or 220 volts. Plug in the standard electrical instrument connector, and we are ready to transfer the instrument to our lab bench and prepare it for analysis.
Correct.
These are the basic setup services required for proper operation of your Model 205 AA. A source of clean air between 50 and 60 psi is required for a proper air-acetylene flame. Acetylene should be set no less than 10 psi and ideally at 15 psi to get the most stable flame. As previously noted, the electrical requirements are 110, 120 volts, 10 to 15 amp for most US service, or 208 to 240 volt for international or industrial service. Prior to doing an analysis, there are several other connections that need to be made on the front of the instrument. The most important of these is the drain line. Included with your installation kit is a piece of soft Tygon tubing. This is inserted onto the black nipple on the right side of the burner head. And after you position the instrument no more than 3 or 4 inches from the front of your counter, you want to prepare a loop to act as a vapor trap, and then using the included cable tie or a piece of duct tape or electrical tape, attach a loop to the system about 4 to 6 inches in diameter. Then using a squirt bottle of water, remove the end of the line from the nipple and proceed to fill it. This will prevent the flammable acetylene gas from leaking into your waste container and causing a possible flashback. Once the loop is full, reattach it to the nipple on the burner head, and this will require very little future maintenance. You will now install the burner shield by inserting the two small pins into the slots on the left and right side of the burner housing, and then tightening the small screw in the back of the burner shield to attach it to the AA. This will direct the heat of the flame upwards and block UV radiation from the user's eyes. For basic operation of the 205 AA with an air flame acetylene flame system, you need to turn the instrument on and select the proper element file from the library included on the system. After that file is selected, you will then peak in the wavelength for the hollow cathode lamp that is inserted in the turret. Then you need to create a calibration curve suitable for that element. Once a satisfactory calibration curve has been created, you can run your samples, and then there are some basic guidelines for shutting down to ensure the stability and long life of your instrument. Turn on the instrument by pressing the power button on the right side panel of the unit, and like any microprocessor-based system, wait a few moments for it to initialize and set itself up for display. The system displays the active analysis window, which is where all of your analytical information will be seen. To set up for an analysis, press the Select key, which will enter you into the library mode. And using the up and down arrows, select the elements you want for this particular lamp. Now notice in the upper right corner of the display, there's a lamp designation, lamp 1, lamp 2, and lamp 3. Make sure the proper lamp is loaded with the hollow cathode lamp based on the file you select in the library. In this case, we're selecting copper for flame work. By pressing 2 and enter, replaces the previous file, which was calcium, with copper, and you can see that in the upper line of the display. Once this is done, press escape. As we follow the directions on the alignment screen, you will set the slit size on the right side of the instrument, and also approximately set the wavelength. Please be aware that the wavelength counter is an approximate setting and may have a variation of as much as 1 or 1.5 nanometers from the true wavelength position. Once we insert the hollow cathode lamp and go to the alignment mode, we will use the bar graph and energy readings to actually set the specific wavelength. The Buck 205 AA system comes with 3 lamp power supplies labeled on the ends 1, 2, and 3. Okay. The socket has a keyhole to match the key in the end of the 1.5-inch hollow cathode lamp. Again, be sure you have the right lamp socket based on the elemental file you've loaded. Insert the hollow cathode lamp and insert it into the spring-loaded clip on the left side of the instrument. At this point, we are ready to go to our alignment screen. Press the Align key and begin to optimize the energy of the hollow cathode lamp by fine-tuning the wavelength and looking at the bar graph signal or the energy number reading to maximize this energy. Once you have the correct hollow cathode lamp inserted into the proper lamp socket, we can now press the Align button, which will show us a bar graph of the energy based on the wavelength setting. Please be aware that that bar graph and the energy number above it represent the same thing, and you can set it either by the maximum energy number or the maximum position of the bar graph. As you rotate the wavelength adjustment knob, the bar graph may go off scale, depending upon how it's set. You may bring this back to the center point by pressing the Align key which normalizes the position of the bar graph. Continue to make your adjustments, but please be aware it is not necessary that the end of the bar be at the 0 position. It just must be somewhere on the screen display. Once you have set the wavelength to get the optimum results in your analysis, you will also want to adjust the position of the lamp to see if you can optimize the energy even further. The lamp holder assembly on the left side of the 205 AA system includes 2 silver knobs to adjust the horizontal and vertical positioning of the lamp so that the beam is centered into the optical system. Rotate those knobs 1 or 2 revolutions or more if necessary, while observing the bar graph or the sample energy reading to see if the energy can be increased even further. This will allow you to get the best detection limits and have the best stability possible. Once the energy has been maximized based on the position of the wavelength and the lamp, press the escape button to exit the alignment screen, auto-zero the electronic energy signal from the hollow cathode lamp, and get to your active analysis screen. At this point, you should see a display showing approximately 0.000 absorbance units. At this point, we are ready to fire up our AA and begin our calibration curve. Make sure that your gas tank's valves are open and your regulators are properly set to the required pressures. Rotate the valve for the air from off to air, and you will see a float appear in the flow meter. The airflow should be somewhere in the middle, anywhere between 4 and 7. At this point, turn on your acetylene valve, and again you will see the float for the flow meter for the acetylene approximately 1 or 2 units less than the setting for air. At this point, open your burner shield and ignite the flame. The little blue feather that you get should be approximately 1 or 2 millimeters high for a typical flame, and only needs to be changed in the case of doing chromium, which requires a rich flame. At this point, close the burner shield and aspirate your DI water or dilute acid blank to keep the burner head cool. It is recommended that the burner not run dry for more than a few minutes because the heat may deform the polypropylene spray chamber after a while. Once you have your standards prepared, it is a good idea to press auto zero while aspirating your blank, and then checking the absorbance signal, the raw data signal from your standards, just to see that they were prepared correctly. Again, you should see something at least a 0.04 absorbance signal for any calibration standard to ensure good stability. Here for copper, we see we've got about a 0.15 for 1 ppm and a 0.6 for 5 ppm. So our standards are in the right approximate range. Go back into your blank. Always wait a few seconds for the solution to equilibrate in the flame, and then we proceed to do our calibration by pressing the Cal key. And for a new analysis, the default has a third order cubic calibration curve, which is not useful. So press option 3 and select either a first order linear or a second order quadratic if you have multiple standards. Linear and first order and quadratic second order are acceptable for most government and analytical work. Then you will press option 1 to select your calibration values. Press enter to enter the concentration mode as opposed to the absorbance mode, and you will see the first line highlighted. The 205 uses a fixed decimal point notation, so using the cursor arrows, scroll over to the decimal point and enter in your first standard, in this case 1.0, and press enter. Then aspirate your 1 ppm standard. Wait a few seconds for it to equilibrate and press the read key. This will take a several second integration, and put the value in the absorbance column of your calibration table. Scroll down to the next line. Use the cursor arrows to move across to the decimal point. Enter in 5.0. Put the standard tube in the 5.0 ppm standard. Wait a few seconds and press the read key again. Once the standards have been run, go into your blank. Press the escape key. You'll see your options there. Press yes to calculate the concentration curve, and then press the enter key to actually see the graphical curve. If this looks satisfactory, you may press the escape key 3 times to return to the active analysis screen, and you can see we are now in the ppm mode for concentration analysis. At this point, we can check a standard or a sample and get our readings. For most flame AA work, you'll aspirate your sample or standard, press the read key to take an integrated reading as opposed to looking at the real-time jumpy readings. A relative standard deviation of plus or minus 5% is completely acceptable for most flame AA work. If any of your standards are outside of range, you can go ahead and do a recalibration by pressing the cal key and repeating that procedure. Once you have verified that your blank and calibration standards are accurate, you may aspirate your sample, wait a few seconds for the reading, and in this case we can see the bright yellow flame is due to high levels of sodium. Press the read key to read your parts per million copper in that sample solution. Take several readings, and you will be able to average them out and generate some calculations for statistics for your sample. When you're ready to run a fresh sample, it is recommended you go back into your blank solution to flush out any high dissolved solids and press the escape key to free up the display as you watch your blank return to 0. You may continue with your analyses, checking your standards every 10 sample readings approximately to verify the accuracy of your calibration curve. At the end of your analyses, you will want to aspirate approximately 50 to 100 milliliters of deionized water to make sure that any salts, organic material, or other things that may precipitate in your spray chamber are flushed out. 50 to 100 milliliters of water should be sufficient to rinse out any residual material.
It is backing up a little.
Once you've rinsed out the spray chamber and burner head with your deionized water, remove the Teflon sample line from the beaker and let the burner run dry for a few seconds to make sure all fluid drains from the system. At this point, you may shut off your acetylene. Wait a few seconds for any acetylene gas to dissipate. Shut off your air. And if you're done with the instrument for the day, you may shut off the power or simply turn down the screen contrast using the little silver knob in the upper left corner so that the lamps are kept warmed up for analysis in the near future. Buck Scientific recommends using a good reference book for atomic absorption spectroscopy to give you guidelines for sample preparation and calibration information. For best stability and good blank recoveries, it is recommended that 1 to 2% of either nitric or hydrochloric acid be used in all solutions to prevent hydrolysis and precipitation. At the end of running any high solid samples or high salt materials, run approximately 100 milliliters of your blank or deionized water to rinse out the burner head and the spray chamber to avoid carryover contamination. It is highly recommended that your acetylene fuel tank be replaced when the pressure on the cylinder drops to approximately 75 or 100 psi, or the acetone that is used to prepare the acetylene under pressure may damage your flow meters. Maintain the instrument at a fairly constant temperature for good wavelength stability. Otherwise, frequent recalibration of the wavelength setting may be needed. Thank you for being a Buck Scientific customer. And if you have any questions as to the operation of your Model 205 atomic absorption spectrometer instrument, please refer to the complete manual included with the system. There is also a short form mini guide to allow you to quickly set the instrument up for rapid analyses. But if necessary, you may call Buck Scientific at our toll-free number, 800-562-5566, for telephone support in an emergency, or send us an email to support@bucksci.com. This way you can document your difficulties to us, and you will have a hard copy of our reply to help you out. Thank you.